Hello, I am Riganko Hallar and now I am pursuing MSc in Statistics from Benares Hindu University and uh, I do a internship program from the Codsoft and this is my last task of the course of internship program, that is credit card detection, and I import the dataset from the Kaggle website. This is the dataset credit card fraud detection, and the information of the dataset is uh, this is many information, but uh, I give the important information, that is features class is the response variable. It takes value 1 in case of fraud and 0 in case of not fraud otherwise. Okay, and this is the mm, important information, and it contains only numerical input variable which are result PCA transformation, and this is their features v1 to v28, the principal component. Okay, and I completed my task in the Python programming and VS Code. Okay, so at first I imported some necessary libraries, that is NumPy, Pandas, matplotlib.pyplot and c1. This is my working library, and then I import my dataset. This is this by code pd.read_tsv, and this is my the dataset, and this is dataset my. Okay, there are v28 columns and amount and class. Okay, and we check the shape of the dataset. Each data.shape, there is 2,84,807 rows and 31 columns, and data contains this column, that is time v1 to v28 and amount and class. Okay, and we check the information of this column, this by code data.info. There v1 to v28, this is the float values, and amount is also float, but class is the integer value, and this is also binary value. This is the 0 and 1, text 0 and 1. Okay, and we at first we check the any missing value of this dataset by this code data.isNull.sum, and there is no missing value. Okay, and here is a column, this is time. Okay, this is not a important uh, of my task. This is of my task, this is not necessary, so we drop the time column, and by this code data.drop time column, and this is my working data set, and this without time columns. Okay, then we. Okay, then data.class is unique, so we check the class values. There is two values, this is the 0 and 1, this is also the binary values, and okay, this is my important column of this project. Okay, here 0 means not fraud credit card, and 1 means credit card is fraud. Okay, and we checking the duplicated value by this code data.duplicated.any. Yes, this is the duplicated value, and we see the which of this column is the duplicated. Then by this code, this is the 33 rows and 35 rows, this is the duplicated value contains, so we remove it. Okay, so data dot duplicated keep first in place true, so remove the duplicated value to we in place to in place the first rows. Okay, first taking rows values, and we removed it. Okay, and we remove the duplicated value, keeping the first, and this is the duplicate, and we also again will also check the duplicated. There is no duplicated value. Okay, and data dot save is 2,75,663.30. Okay, so we remove the duplicated value because the previous save is 2,84,807 and 31, and again we dropping the duplicated value or save each 2,75,663. Okay, and we check the some descriptive analysis by data.describes, and this is the class maximum value is 1 and minimum value is 0. Okay, Okay, and we check the length of the zeros values of the class. This is the 2,75,190 and one values. This is the fraud. This is 473. This is very less comparison, and this is very high. Not fraud value is high, but this is fraud value is very low. Okay, and we draw the count plot by this column. This is the zero value is high, that is not fraud. Credit card value is high, but one is very low. This is overlapping the our x-axis, zero columns, very less. Then the not fraud. So credit card fraud is very the number of the credit card fraud is very less than the fraud than the not fraud. Okay, and we we extract the our dependent variable and independent variable. Here the dependent variable is all class without class, all data, all columns without class, and our uh, dependent variable is class. So we predict the sum model on the y. Okay, this is our y is our response variable, and this x is our regression variable. Okay, so I am treating the appropriate model, and that at first we import the library stats model.sci.sm, and this is our regression variable. So we add constant sm.add constant and logit model, and we fitted the logistic model. And because the our y this distance variable is the binary data, so we fit the logistic model. Okay, and this is our the summary of the logistic model, where the log likelihood value is this, and log log likelihood without dependent variable this. Okay, and this is our regression variable with coefficient this, and this is the probability value. Okay, so this is the G statistics. We check the model is best fitted or not. Okay, so this is the G statistics, is -2 multiplied by LL null minus log likelihood, and this value is the 4,747.8. Okay, and here the number of independent variable is 29. So I misspelled this. This is the 29, and our null assumption is the coefficient of dependent variable is 0. So our model is significant. Okay. So here the probability values greater than 0.50. These columns V2, V3, V1, V12, V15, V19, and V24. So this is the significant. This is the insignificant column. Okay. So we import the SciPy, and we import the chi-square from the SciPy.stats, and we calculate the probability value, chi-square probability value with these values for 4,070%, and there is the independent. There's the independent column is 29. So this is the degrees of freedom. This value is 0. That is our value is less than 0.05. So our model is significant. Okay. So we reject our null hypothesis that our dependent variable with coefficient 0. So this is our model. This is we rejected. So this is our model is significant. Okay, and we import the train test split by from the scale and model selection and logistic regression, and we with our this is our input data. Okay, this is our input, and y is our output. This is the response variable class, and we split the train test size 0.8, and okay, random state 22, and length of the trained variable is the 2,20,530, and the test variable is 5,051 33. Okay, 55,133. Okay, this is our logistic regression, and we feed the x10 y10, and we feed it this, and this is our the predicted value. Okay, y predict lrd dot predict x10 dot arrival. This is our the predicted value, and this is our the actual value. So this is model is 0 0 compare and last value 0. This is same. So we check the model good fitted or not. So LR easy to score X test twice. This is value is 0.99. So our model is best fitted. Okay. So and we check also accuracy rate, and this is also 0.99. So this is best fitted. And we draw the confusion matrix. This by code from sklearn matrix import confusion matrix and confusion matrix y test x, where we give this array. Okay, this confusion matrix contain the predicted value and the actual value, and this array is arrays this corresponding rows is our the predicted value and corresponding column is our the actual value. So this is the 55,050 is our the true negative value, and false positive value is 6, and false negative value is 37, and true positive value is 40. Okay, so we print these values, and false true negative is 55,050, false positive is 6, false negative 37, and true positive is 40. Okay, and we from scalar matrix we import the classification report, and we draw the classification report. That is, and this classification report precision, contains precision, recall, F1 score, and support. Okay, so the classification report contains the recall value. So this recall value gives an idea about it actually is. So this is actually yes, and how often does it predicted yes. Okay, recall value is gives the idea when actual value is yes and the predicted value is yes. Okay, here recall values with respect to one is called sensitivity. Recall value with respect to one is the sensitivity. So here sensitivity is 0.52. This is the true positive by plus false negative. Okay, and the diagonal values of the classification report is true value, that is true positive and true negative, and precision tells about when it predict yes, how often it's correct. Okay, the precision value is the prediction is yes and how often it's correct. So precision is true positive upon false positive plus true positive. Accuracy is the true positive plus false negative upon true positive plus false negative plus true negative plus false positive. And a recall or sensitivity is same. This is the true positive upon true positive plus false negative. And F1 measure, F1 measure is the 2 multiplied by recall upon recall plus precision, and a harmonic mean of the precision and recall is used to indicate a balance between precision and recall, providing each equal weighting. It ranges to 0 to 1, and F1 score is best when it is the 1, this is the precision and recall, and worst is 0. Okay, so F1 score is 1, so this is our model is best good. Okay, accuracy, we calculate the accuracy precision by its manually. This is the true positive plus true negative by true upon the true positive plus true negative false positive. This is the accuracy is 1, and precision is also 0.87. This is also the precision value. Okay, precision is 87, and recall value is the 0.52, and this is our the recall or sensitivity is all same. So recall value is 0.52, and specificity is the 1. Okay, and I completed my task very enjoyfully and gratefully, and I learned many things, coding soft skill tools through the internship program. And many thanks to my LinkedIn profiles followers for encouraging me, and thanks a lot to Codsoft for giving me a chance to do this type of coding exercise internship program, and I am grateful to the Codsoft.